I am Dr. Namasivayam, Associate Professor and Head, Department of Physics, working in this esteemed institution for the past 37 years. Today, I would like to discuss a little bit on motion on an inclined plane. And we all have seen motion on a normal surface, and by Newton's law, for every motion there needed to be a force. On a horizontal surface, there will be a force that is responsible for motion. And today's topic is an inclined surface. When I say inclined, it is just one plane over the other and it is not horizontal. And if you expect any motion in it, there can be a force, or even without a force, the object can move. So today I would like to start with motion on a smooth inclined surface. So let us consider an inclined surface. I just consider an inclined surface, and this is a level ground. Whenever we draw this is nothing but the horizon or the level ground, and the plane that I consider AB is inclined to the horizontal by an angle theta. And I said it is a smooth surface. When I say smooth, there is no friction. And I keep an object here. The object is placed on it. Now the several questions can be asked. How long the object takes to reach the level ground, with what velocity the object will reach the level ground, and so many things can be asked. But before going into it, we should know the acceleration experienced by it. Do we have any force here? I am not applying any force, but there is a force. What is that force? It is only the gravitational pull. If I consider the object to be of mass m, it is a weight that is acting vertically downward. So the one and only force which is hidden, not applied, it is acting on it. It is actually acting. And due to this, the object will slide. You will be questioning, there is no force parallel to the surface under consideration. Now we have to zoom this part. Will it act parallel to the surface or perpendicular to the surface? Let me just zoom it on the board. So I would like to zoom the forces that are acting on it. Having said that, mass is actually m placed on an inclined surface AB, the same diagram. I said weight is acting vertically downward. So there is a force which is acting in this direction, and it's a natural force. So what is that force? Mass into acceleration due to gravity is weight. That is a force. But I expect the motion to happen in this direction. This is the direction in which I expect the motion. So there has to be a force in this direction. How to find? Let us resolve the vector into its components. So I have a force which is acting vertically downward. If I resolve it, one will be acting parallel to the surface, other one will be acting perpendicular to the surface. The perpendicular to one will normally provide the reaction component, and the one that acts parallel to the surface will provide the force responsible for the sliding action. So let me find the components. So this force M is resolved into two. One this way, the other one is perpendicular to the inclined surface. Having taken the angle of inclination as theta, this angle is also theta, we all aware. On resolving, adjacent side is actually what? It is a cos component of the force, so it is mg cos theta, and the other side is mg sin theta. So now we find the force which is acting parallel to the surface and down the stream. So that makes the object to slide. We find the children sitting on a slide go on their own. They get accelerated as they come down. That means there is an acceleration. Now we can find the acceleration. Now we all aware acceleration is equal to what? Acceleration is equal to force per unit mass. Am I right? Force per unit mass. Now what is the force that is acting on it? mg sin theta. And what is the mass of the object? M. Cancelling these two, acceleration responsible for motion is g sin theta. That's it. Once you know the acceleration, you can use the acceleration for any of your problem. Suppose I want to find the velocity when it reaches the bottom. V is equal to what? U plus at. What is A? This is A. Sir, I want to find the time taken by it. S is equal to how much? Ut plus half at square. What is this A? This is nothing but this. Sir, I want to find the velocity using other relationship. V square is equal to what? U square plus 2as. What is it? A. This is. So, once you know the acceleration, you can use it, from which you can find the rest. Is it clear? So, any object that slides on the surface will have an acceleration parallel to the surface, which is nothing but what? That is nothing but g sin theta, where theta is angle of inclination. Is it clear? That's it. Now, let us move on to the next one, that is on a rough surface. I have taken a smooth surface where there is no friction. So, it is easy to find A, but let us take a case where once again we find the acceleration on an inclined surface, but with the friction. Artha sir. Sorry. Here, once again, I consider the same mass placed on the same inclined surface. The angle of inclination theta is generally called what? Angle of inclination. Terminologies are very important. Angle of inclination. Okay. Now the mass is placed on the surface, and I consider a surface where there is a friction. The coefficient of friction is generally referred as mu. If it is static, we take it as mu r. Once the object starts moving, it is kinetic. Normal sense, we assume the object to be moving, so we can straight away take it as what? Mu, where mu is the coefficient of friction. So I consider a surface where there is a friction, so I put it across. I say that it has a coefficient of friction mu. Now once again I am going to find the force that is responsible for motion. I have not applied any force. Now it is only the weight that is acting vertically downward. As I said earlier, there has to be a force parallel to the surface. So let me resolve this into two. So I find a force acting in this direction, and similarly I find one more force that is acting perpendicular to the surface. Am I right? So this is, so this angle is theta and weight is acting vertically downward. On resolving, we find mg cos theta perpendicular to the surface and mg sin theta parallel to the surface, responsible for motion. Sir, there is a friction, and where does it act? It acts parallel to the surface, against the motion. Having considered the motion to be downward, your frictional force will be acting upward. Let me mark the frictional force. Where exactly it is acting? It is acting at the point of contact or parallel to the surface. It acts here. This is the frictional force. Is it clear? Could you see it? This is the frictional force. Generally, it is convention to refer it as what? F sufficient suffix SFR. That is, FFR refers frictional force, and we all aware that frictional force is directly proportional to what? The normal reaction, or equating it mu into R. I think I can put it this way. FFR is equal to how much? Frictional force is equal to mu into R, where mu is the coefficient of friction and R is the normal reaction. Sir, we don't have normal reaction here. We have to find. So normal reaction is nothing but the reaction experienced by the surface, by the object, due to the surface. Always it is acting perpendicular to the surface and against the component which is acting due to gravity. And here I find the force which is perpendicular and against this one. So this is my normal reaction. Is it clear? This is my reaction, of course perpendicular, so I call it normal reaction. So this is the normal reaction R. Normal reaction R. Now there is a force which is acting in this direction, which is responsible for motion. Am I right? That is a pulling force. This is a force which is pulling the object in this direction. Right? This is a force which is pulling, but it gets opposed by friction, which is acting in the opposite direction. This is against. When two vectors are acting in opposite direction, we normally find the motion in the direction of the force which has more magnitude. If I expect a sliding, then mg sin theta should be more than the frictional force. So ultimately, I get the acceleration in this direction, where parallel to the surface. So this is the direction in which I get acceleration. Now I have to find the resultant force responsible for motion. Let me just type it here. The resultant force responsible for motion. Resultant force responsible for motion on the inclined surface. Inclined surface is equal to how much? Is equal to the force which is responsible for it pulling it downward is mg sin theta, which is actually opposing. Opposing is actually the frictional one. So minus FFR, frictional force. This is the force. So what is acceleration? Acceleration is equal to force divided by mass. So once again I rewrite it as what? mg sin theta minus FFR divided by m. Then what is FFR? Here I have written it as FFR is equal to mu r. Do you know the reason why that we write only FFR is equal to mu sin theta? Mu r. Now this is the object which I have. Am I right? This is a mass which I have placed. The two forces that are acting on it are, one is acting perpendicular to the surface and downward, that is mg cos theta. And what about the reaction? Reaction is actually acting in this direction. Do you find the object going into the surface? No. So as far as the vertical side is concerned, perpendicular to the plane is concerned, there is no motion. So we call it equilibrium. So when I say that it is in equilibrium, the forces are equal and opposite. Ultimately it experiences no force. One is mu r. What about the other one? This is reaction in fact. This is reaction and this is mg cos theta. So at equilibrium, I can write it as equilibrium. R is equal to how much? Is equal to mg cos theta. So I can make use of this. I can just take it to this equation where I have FFR. And what is FFR? Mu r. So my equation getting changed to mg sin theta minus mu r is actually what? Mu into mg cos theta divided by m. So ultimately it is going to be what? G sin theta minus mu g cos theta. Now this is acceleration. And once again you can use this equation, or you can use this acceleration in all your equations, like v is equal to u plus at, s is equal to ut plus half at square. In all these equations, what you want to find is a, and that a is nothing but what? G sin theta minus mu mg cos theta. We will see one or two applications. Just now we have seen the vectors using a zoom board. Just I have analyzed how the vectors are getting resolved, how exactly motion takes place. Now we are very clear that this mg is getting divided into 2, or it is getting resolved into 2. So basically this is mg sin theta. Of course I have to mark the angle. So this is mg sin theta and this is mg cos theta. Mg cos theta. And I would like to find the acceleration in this direction, and this is the force. So once I know the force, knowing the mass, I can find acceleration. So acceleration is equal to how much? Is equal to mg sin theta is the force divided by mass of the object. So a is equal to what? G sin theta. G sin theta. There is one more way of discussing this sum. I have taken the force into account. It is not a must that we have to always consider the force. Directly we can find the acceleration. I'll tell you a way. If this is an inclined surface, correct? Acceleration due to gravity is the only thing that is acting on it. That is A is equal to what? G. But I expect acceleration in this direction. So straight away I can resolve this. This is also a way by which you can do. And now this is an inclined surface. So this is theta. So this is theta. And again I can say that this is cos theta, G cos theta, and this is G sin theta. Have you got it directly? Instead of finding the force and doing for acceleration, directly I can resolve. The reason is acceleration is once again a vector quantity, and you can find the component that is responsible for motion in any direction using the simple resolving of vectors. And this is on a smooth surface. Now let us move on to a rough surface. What is a rough surface? If I consider glass, it is sliding over. Of course it has friction, but on theory we assume that there is no friction. But if I consider the board, I find that there is a lot of friction. So when there is friction, I have to use the term coefficient of friction. So I would like to consider one more inclined surface that offers a little bit of friction. We will see it. So I consider once again an inclined surface. Am I right? First we have seen smooth, now this is rough. So I consider the same inclined surface, and here is this is nothing but the level ground. Level ground is nothing but the table on which you do the experiment, and this is in the shape of a wedge. Normally problems are asked on a wedge. This is a wedge shaped one, and here I consider a mass. But one more information I have provided, that this surface is not smooth. The surface offers a friction. So I would like to introduce mu is called coefficient of friction. Coefficient of friction. Now once again, if I find the weight is acting vertically downward. So this is mg, the only force that is acting on it. Upon resolving, we find there are two forces, one parallel to the surface which pulls it down, the other one presses the surface, that leads to reaction. So here this is going to be mg cos theta and this is mg sin theta. I have not discussed anything about friction. Now why? Friction comes into play only when the object starts moving. At first there is no friction, and friction is actually called a self-adjusting force. For example, I need 10 Newton to push an object. If I apply anything less than 10, it doesn't move. What does it mean? When I apply 1 Newton, it experiences a repulsive force of 1 Newton, so it doesn't move. For example, this is an inclined surface. I think we have a board. It's not a vertical board. I'm just placing it. It is sliding. Why it slides? Because the downward pull is more than the friction. It's a frictional one, but still it slides. Why? The force is more than the frictional force, it starts. In case if it is less, what will it do? It doesn't move. Suppose I have a surface and here I am keeping an object. It is not a must that it has to slide. Why? The force that is acting in this direction is less than the required force to move across. The friction is more. But when I apply 1 Newton, the friction comes into play is also 1 Newton. When I apply 2 Newton, the friction comes into play is 2 Newton. Suppose I have to have 3.5 Newton to pull it down. Till it reaches 3.5, the frictional force keeps on increases. At 3.5, it is about to slide. And when you apply more than 3.5, it slides. But thereafter, the frictional force is always the same as expected. It is going to be 3.5. So frictional force is a self-adjusting force. So it comes into play only when the object slides. So I expect acceleration in this direction. As the object is going to slide down, there is going to be a friction and which is acting in this direction. On the surface against the motion. As the object is moving down, frictional force will be acting in this direction. And what is FFR? Frictional force is equal to what? Is equal to mu into R, where mu is called coefficient of friction and R is normal reaction. So I think I have to find that part, R. What is R? Reaction comes into play here. Now this is a reaction. Am I right? This is a reaction. Now this object is in vertical equilibrium. This is my object, where mg cos theta is actually acting, or it is pressing the surface. So the object experiences a reaction in this direction. So this is R. As the object is not moving in this direction, so this is an inclined surface, the object is not going to go inside. R is equal to how much? Is equal to mg cos theta. I used to say it is in vertical equilibrium. So R is equal to mg cos theta. So this can be used to here. So FFR is equal to how much? Is equal to mu into mg cos theta. Sir, I want to find acceleration. A is equal to what? The force that is pulling down is mg sin theta, which is opposed by the frictional force. So that is a net downward force divided by mass. But FFR is equal to how much? Is equal to mu mg cos theta. So A is equal to mg sin theta minus mu mg cos theta divided by m. So A is equal to how much? Is equal to g sin theta minus mu g cos theta. Now we have discussed two motions without applying any external force. What happens if you apply a force? I am just leaving a question to you. You have to think about it. I would like to give you just the diagram with force. You can just carry on with it and you can find acceleration as discussed now. Is it clear? Okay. Motion on an inclined. Force applied. அவ்வளோதான். அப்படி கண்டுபிடிக்கிற சார். So in the earlier two cases we left the object as such. Now I would like to apply a force. What type of force do I have to apply? You just assume that a child is sitting on a slide of mass m. Okay, mass m. Father is standing downward and he is just pushing the child parallel to the surface. So he is going to apply the force in this direction. So in addition to the natural forces that are existing, I apply a force in this direction. So object is placed on the inclined surface. Force is applied parallel to the horizontal surface, not to the inclined surface. Now what are the forces that are acting already? Now weight is acting vertically downward. As this is theta, I would like to resolve it into two components. One is mg sin theta, expecting it to move down, and this is theta, this is mg cos theta. Mg cos theta. And what about normal reaction? Normal reaction will be acting in this direction. In addition to that, I have applied a force. But that force is neither parallel to the surface nor perpendicular. If I apply a force parallel to it, then I can push the child up. If my force is insufficient, then the child will slide down. So I have to find the component of the force. So I have to resolve this into two. I have to resolve this into two. Do you understand? I have to resolve. As they are alternate angles, again this is theta. So you have applied a force F cos theta parallel to the surface, and F sin theta is acting perpendicular to the surface and downward. Now if I say that the child is moving upward, my acceleration will be in this direction. Am I right? My acceleration will be in this direction. Now what about the frictional force? The frictional force is always against. So I expect a frictional force in this direction. Am I right? So frictional force cannot be drawn along with the diagram. Only after ascertaining whether it is going to go up or go down, you cannot draw frictional force. So having seen that the child goes up, the force is sufficient to pull it upward, my frictional force comes in this direction. Now I have to write down the equation. See how many forces are acting? I can do one thing. Just I can find the forces that are acting parallel to the surface, and I can find the forces that are acting perpendicular to the surface. In vertical equilibrium, what are the forces that are acting? R is acting vertically upward, whereas the other two forces are what? Mg cos theta is acting downward, and the other force is actually F sin theta. Both the forces are acting here. This is vertical equilibrium. So my equation is actually what? R is equal to mg cos theta plus F sin theta. Sir, what about horizontal forces? As far as horizontal forces are concerned, the force which is responsible for motion is F cos theta, whereas the weight component is acting in this direction, that is mg sin theta. And in addition to that, I have found the frictional force which is against acting the motion, FFR. So what is this FFR? So here I expect the object to go in this direction. So equations are what? Equations are A is equal to F cos theta minus the net downward forces are what? Mg sin theta plus FFR. Sir, here what is the equation? is equal to so much. Up F of r is equal to how much? Is equal to mu into r is equal to mu into mg cos theta plus f sin theta. See this actually? This is an extension, that's all. So initially we have seen a case where there is no additional force acting, on its own is sliding. Now we see a case where the force is acting in some direction. I say the child is pushed with a horizontal force. I am just pushing it this way, but the child has to slide over. So I have to find the force which is acting parallel to the surface and upward. On resolving, the force that I have applied, see this, the force that I have applied here has a component that enhances the reaction, therefore friction experienced by the child is more. So if you want to push the child, what you have to do? Push it parallel to the surface, don't push it horizontally. If you push, then the child finds her dresses getting torn. The reason is it experiences more friction. Why? Because you have applied a force, a component is acting downward, increases the reaction, increases the friction. Friction is always a devastating force. It's a necessary evil. Friction causes slippers to go off. Wear and tear, tires are getting wear and tear only because of friction. But if there is no friction, you cannot move. So normally we say what? Friction is a necessary evil. So friction plays a vital role. So we have to consider the direction of the force that is to be applied to do our practical things. We find physics in all our endeavors. Bye.